Where we left off in the last video, we talked about how this is a square, but how to prove it. First, we have to prove that it's a rectangle and a rhombus. But we're going to move on from there to look at question number 6. Question number 6 says an experiment consists of spinning the spinner shown. All outcomes are equally likely. What is the probability that the spinner will land on one? Express your answer as a fraction in simplest form. What is probability? What is it over what? Desired over total. That's absolutely right. So what is desired out of this? And how many ones are there? So there's 1. How many total outcomes are possible? 5. So we should get 1/5 as my probability. Okay? So hopefully, we'll try to keep an eye on our answer key here and make sure that I'm not giving you anything that's incorrect. Okay? 1/5. Okay, let's take that out. All right. We take probability and we get a little bit more difficult with it in question number 7. Okay. Number 7 says a circle is inscribed in a square with a side length of 4. If a point in the square is chosen at random, what is the probability that the point in the square is in the square but not in the circle? Okay. Express your answer as a percent, round to the nearest tenth. So what we're saying that we want is we want to know what is the probability of, let's say, throwing a dart and hitting those blue shaded areas, right? So remember, the probability is desired over total. In this case, it's area over area. So desired area over total area. Well, total area is not too hard to find, right? What is the total area of that entire figure? 16. You just took 4 times 4, you got 16. Great. But the top, how do I find that? How do I find the area of the shaded region? Just as a general. Okay, so area of the square. So we'll take square minus circle. Well, the nice thing about it is we already know what the square is, right? What is the square? 16, all right? Now we need to subtract. How do we find the area of a circle? Pi times the radius squared. So we're going to subtract pi. What is the radius of this? 2 squared. So 16 minus 4 pi, right? So we're going to take 16 minus 4 pi, and we're going to divide that by 16. Okay? We can take our calculator to do that. Clear some stuff out. 16 minus 4 pi. Okay? I'm going to hit enter. I'm going to divide that by 16. Okay? That's going to give me a decimal. But what am I going to write this up as? How did it want my answer? 21 point, let's call it 21.5%. It wanted it as a percent, right? To the nearest tenth, right? Is what we saw there. 16 is the total area, right? So what I have, let me just kind of hit it again just so we're clear, okay? Let's move this back to, and right there, okay? So 16 is my total, so let's fix this up here. Total area. It just happens, okay, that my area of my square is my total area, which is why 16 works both times, okay? All right. Does this make sense? You know how to solve that question? A little easier maybe than you expected it to be. All right, let's come down to question number 8. If a can is 20 inches tall, has a radius of 8 inches, how many cubic inches of water can it hold? This needs the volume of a cylinder. Does anybody know how to find the volume of a cylinder? What is it? Volume of a cylinder. Pi r squared times height. Okay, the easy way to think about this, anytime you're dealing with a prism and a cylinder uses the same principles as a prism, it's like counting the bottom all the way up to the top. Okay, that to me helps volume. Yeah, it's a circle times its height. So that's why I'm using pi r squared, because it's the area of the circle times its height. I'm taking it all the way to the top. So once I know that, we can do pi. Radius is 8 squared. Height is 20. Okay, or 64 times 20. Okay, I'm not going to go back to the computer calculator. 64 times 20 is 1280. So you could write that up as 1280 pi. What do they write that off? Yeah, they write it as 1280 pi. They leave it in terms of pi. And inches cubed.
What if on the test you had like
More than one option. So you're asking, like, what if this wasn't multiple choice? Then I would take either answer. If it's not clear. Now, if it had said solve in terms of pi, I would not take the decimal. If it asked for the decimal, I would not take it in terms of pi. Okay? But if it's not specific, I'll take either one. Right? Usually, if it's not specific, I may write above the question what I want it in. Chances in that case is that I'm going to tell you to put it in decimal form, because that's going to be easier for you to type in than to try to write in pi somehow. Does that make sense? Okay. So if you were going to write this as a decimal, we would take this times pi. I would write that as 4,021, and let's just say to the nearest whole, inches cubed. Okay, 4,021 inches cubed. Does that work? All right. All right, number 9. Okay. AD is tangent to the circle. Find at A, find measure angle CAD. Okay, we want to know what that blue angle right there is. Anybody remember what the formula function for that is? What do we do here? Divide by 2. What am I dividing by 2? The intercepted arc. 130 divided by 2. Because angle, this arc, 130 degrees, intercepts this angle. Divide by 2. That equals 65 degrees. Okay? That's the question I want to see on the test, right? Because it's easy, it's quick, right? I can probably get that one right. What's that? I don't know. I feel like one of these days should make an announcement like, lo and behold, golf practice is going to be at the golf course.
Yeah.
Mind blown. All right, find RS. One of the things you need to know about this is that XT is what in this trapezoid?
The mid-segment?
There you go, mid-segment. And I find mid-segment by taking my bases, adding them together, and dividing by 2. It's the average of my bases. So this is like whenever we had questions where I knew the midpoint and I knew the other point, but what was the point on the other side of the midpoint? Right? It's the same process because I don't know what RS is. Okay, but I know how to find XT. So I'm just going to act like I was trying to find XT. Oh, is it? Oh, I'm sorry. My brain, yeah, XY. Yeah, I don't know. And then this guy down here, he doesn't even get a letter. So it's like Q. Who cares? So, all right. So the way we want to do this is we're going to do X plus what? X plus what? 26 divided by what? Equals what? 22. All right. What am I going to do with the 2 in the denominator? Multiply it. So I get X plus 26 equals what? 44. What do I do with the 26? Subtract. 18. Okay. I think I did have one student bring up a really good point one time. They said, couldn't you just take the difference between X, Y, and Q whatever and then subtract that from 22? Absolutely, you could.
Pardon the interruption. Just another brief announcement that there will be no junior high track practice tonight. Thank you.
Okay. So if you know the difference between 22 and 26 is 4, I could take 22 minus 4 and get 18.
Does that work every time?
It should work because, like we said, it's the mid-segment, right? So it should be half, so you just end up subtracting whatever the difference is. Right? But the problem is that what if we knew RS but we didn't know Q whatever it is? Right? I would have to, because I know Q whatever it is going to be greater than, right? So let's say I knew this was 18 up here, then I would have to take the difference and then add, add it too. Does that make sense? So it does depend upon what side it's on. Now, if you use this formula, this will work every time, right? Doesn't matter which side of the mid segment is missing. So just to kind of give you a couple of different things to think about. Let's see, what is this, 11? Find the volume of a rectangular pyramid. Anybody remember how to find, what's the volume for a rectangular pyramid?
That's not it.
That's not it. No, that's circle. Okay, so volume equals base times. Nope, not slant height. Height divided by 3. Okay, and it is interesting, just kind of, it does help, is that with a lot of volumes of different type of geometric figures, 3 is commonly involved. So like with cones and pyramids, we end up dividing by 3. With spheres, it's 4/3, you know, so it's still got a kind of a 3 attached. So my base here, notice that it's a rectangle, so what's the area of my base?
12,
So I have 12, what's my height?
7.
7 divided by 3. Okay, 12 times 7.
No, it's not 6.
You got 60, 84. 84 divided by 3. 28. All right, let me check and see. Let's see this question. Yep, 28 centimeters cubed. So we're finding volume. All right, we'll come down to this guy. Number 12. In this diagram, these are tangent lines. What do I know about the relationship between BF and BC?
BF and BC.
Yeah, BF and BC. They're equal to each other. Okay, they're congruent segments. Because they are tangent lines to circle Q that come back to a singular point, which means they're the same distance. What do I know about AB and BB? They're congruent, but they are obviously not congruent to the other two, right? So from here on, I'm going to fill in. I know that this is 3x plus 2. Okay, BC is 5x minus 2. BD is x plus 8. And BF is 8x minus 11. Now, there's a lot of different ways to solve this. If they want to find the lengths of each of those segments, what do I need to solve for first? X. How do I solve for x in this? Set congruent segments equal to each other, solve for x. So I could set 3x plus 2 equal to x plus 8, or I could do 8x minus 11 equals 5x minus 2. What's probably going to be shorter? Right, so I have fewer numbers to kind of work with if I do 3x plus 2 equals x plus 8. Okay, subtract x, subtract 2. Okay, I'm going to get 2x equals what? 6? So x equals 3. Now, a lot of people will stop there, right? You might even see 3 as an answer. Okay, but I should get just 3, you know, just 3. So what do I need to do here? Plug it in. Now, the nice thing about this is I know, all I need to do is plug it into the easiest one, and the one opposite of it is going to be the same length, has to be. All right, so, you know, 5x minus 2, 5 times 3 is 15, 15 minus 2 is 13. Okay, so, you know, rather than doing 8 times 3 minus 11, I'm just going to go and say, I know that that's going to be 13 because of the rule. Okay? All right, are we good there? Solve for x, plug it in back into everything. Okay, just make sure that you don't put anything in the wrong spot. 13. Surveyor whose eye level is 5 feet above the ground. So we're going to wind up with a building. Okay, we've got a man here, and his eye line is 5 feet above the ground. Okay, he's going to look up to the top of that building. He's standing 40 feet away from the building. He's looking up at 41.7 degrees, so it's an angle of elevation. We want to know how tall the building is to the nearest foot. So the first thing I have to find is the height from his sight line to the top of the building. How do I do that? Tan, opposite over adjacent. X is opposite, 40 is adjacent. So tan 41.7 equals x over 40, right? X over 40. What do I want to do with the 40? All right, so what I'm going to plug in my calculator is 40 tan 41.7. In the video, you would notice that I made a mistake, not because I purposefully did it, but because my calculator was in radian mode, and it came out with an answer that's actually would be on the test. So what is 40 tangent 41.7 in degrees?
35.
Use it. 35.64.
Yeah.
All right, but am I done yet?
No.
No, because x equals 35.64, but we want to find the height of the building, which is another 5 feet above that. So what do I need to do? Okay, plus 5. Okay, 40.64. They want it to the nearest foot, so what am I going to write? 41 feet tall. Okay, 41 feet. All right, 41 feet. Does that make sense? Don't forget to add 5 feet onto that. Okay, because I guarantee you there'll probably be something that says 36. Okay, so you need to know your trig functions. Graph the equation. X plus 4 squared plus y minus 2 squared equals 25. What is that equation graphing? A circle. Okay? So just looking at this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5. Where's the center of this circle at, according to that equation? -4, 2. Okay, so to the left 4, 1, 2, 3, 4, up 2. Okay, do we understand that? Do we understand how we went left 4 and up 2, even though it was positive 4 and it was -2? Okay, it's the opposite of what you think. Okay, now what do I have left to do? What does that 25 represent? The radius, but is it 25? Is 25 the radius? It's the square root of 25 is the radius, right? So what's the radius? 5. 5. So I'm going to count 5 to the right. Okay, 1, 2, 3, 4, 5. Okay, something like this. 1, 2, 3, 4, 5 would be like right over here. 1, 2, 3, 4, 5, something like that. 1, 2, 3, 4, 5, about in there, and then. Okay, it's not great, but yeah, thank you. Okay. All right. All right, let's see. 15, find CA. What do I know about this triangle? It's equiangular, and because it's equiangular, we know it is equilateral, so that means all sides are going to be congruent. What do I need to solve for first in order to find CA? I need to find S, right? How do I find S? You guys have had this question on a test before, so it should be, what is it? I'm hearing everybody talk at once. Set them equal to each other. S plus 2 equals 2S minus 10. Okay, subtract S, add 10. We get 12 equals S, right? Right, the mistake that people make is saying CA must be 12 then and stopping, right? Well, does either of these sides actually equal 12, or does just S equal 12? S equals 12. So what are we going to do with 12? Easier to add 2, right? So I know that this side is 14. I can check that out. 2 times 12 is 24, minus 10 is 14. All right, so CA equals 14. We understand all this so far? I know I'm moving pretty fast for you guys, but are you getting some of it? Okay. All right. Does anybody have the video pulled up? Can you go to like 30 minutes and find out which question I actually ended on? I think I'm going to skip number 16. Somebody pull that up there and tell me where it ends. Okay. Number 17. Find a... What's that? It ends at what? Question 30? No. I ended at, so the time stops at, or it actually, there's sound for question 11? Is that right? Yes or no? We are recording now. I'm going to have to hit pause on this while somebody...
And then it flies like there's a cut, there's like a quick cut, and then it's, sorry, my audio was not on.
Yeah, a guy came in to change the filter, in which case I paused the video, and I looked down, I'm like, my mic is off. And shoot. All right, number 17. Find the probability if a point chosen randomly intersects, is inside the circle, is also inside the trapezoid. So we want the area of the trapezoid over the area of the circle. That's how probability would work there. The tricky thing about this one is that these notches are not ones, they're actually halves. Okay, so my pi r squared down here is actually 5. So we got pi 5 squared. Up here, we need to know how to find the area of a trapezoid, base 1 plus base 2 times height divided by 2. All right. So I'm counting 1, 2, 3. Okay. 1, 2, 3, 4, 5, 6. 3 plus 6. 1, 2, 3. So times 3 divided by 2. Right? So then we're going to simplify this. So we know we're going to have 25 pi down here. 3 plus 6 is 9, right? 9 times 3 is 27. 27 divided by 2 is
13 and a half.
13 and a half. All right, 13 and a half. So we want 13.5 divided by 25 pi. We want our answer to the nearest hundredth.
Plus 7.
0.17, because we want to round that up to the nearest hundredth. Okay? Now, you might complain that I didn't do number 16, but I'm pretty sure that if you watch the video, you'll at least understand number 16. Okay? Even without sound, you should be able to get something out of it. Question? 13.5 divided by 25 pi. Now, you do have to make sure that you put 25 pi, all in parentheses, because otherwise it's going to take 13.5 divided by 25, or times 3.14.
Okay.
Okay? All right, let's move on. Got it? Great. All right, 18. Oh. For an art project, Anna needs to spray paint a can of soup. All right, so what we're looking for here is surface area of a cylinder. Okay, so that's going to be perimeter times height plus 2 pi r squared. Okay, perimeter times height is going to give me the lateral area. The 2 pi r squared is going to give me the area of both bases added up together. So, in fact, perimeter is actually 2 pi r h plus 2 pi r squared. So that's actually the full surface area of the cylinder. So surface area here is 2 pi. My radius is 1. My height is 5 plus 2 pi 1 squared. I'm going to leave this in terms of pi for as long as I can. So I get 10 pi. 1 times 5 is 5, or times 2 is 10, plus 2 pi. Okay. So what I'm plugging in my calculator is 12 pi.
37.37.
To the nearest whole should be what? 38. 38 inches squared. Okay. 19 is really easy. It's reflection, right? Okay, 20, surface area of a square pyramid, right? This one's a lot easier than a hexagonal pyramid because the area of the base, right, is a lot easier to find. So, but we still need perimeter. So I'm going to get 4 plus 4 plus 4 plus 4. So let's go ahead and write this. We got perimeter times slant height plus my base, okay, where this is divided by 2, right? Okay, so my perimeter is 16. My slant height is 9 divided by 2 plus area of my base, which is 4 times 4, which is 16. So 16 times 9 divided by 2 plus 16. Did I do something wrong?
No. I'm doing ahead. It's not.
Well, 16 times 9 is 144 divided by 2 is 72 plus 16. I get 88. And I want to make sure that that's right. 88 centimeters squared. Okay. Let's see, 21. 21's kind of a time consumer, but we'll get done what we can get done. All right. So we have our plane in the air, and it has a line of sight. Down here, I have my runway. He's going to look down. He's going to see the beginning of the runway. He's going to look down. He's going to see the end of the runway. The question is how long is the runway itself? Now, he's 1.8 kilometers in the air. Okay, so that height is the same on both of those, but the angle of depression is different. Let's see. What is he, when he sees the beginning of the runway, should be the greater of the two angles. What's the greater of the two angles? Oh, it's right down here. 31 degrees, right? So 31 degrees is my blue. Okay, that's that whole thing. And then this guy right here is 23 degrees. So what we're going to do is 23 degrees. What we're going to look for is we're going to look for this whole length here. And we're going to look for this length here. And we're going to subtract the blue from the red. You follow me? And that's going to give me just what's left over. So what we want to use is, because we're using opposite over adjacent, we're going to start with our long. So we're going to use tangent. Let's see, tangent 23 equals 1.8 over x, which is going to result in 1.8 over tangent 23. Can anybody tell me what 1.8 divided by tangent 23 is? Give it to me to the nearest hundredth. 4 point what? 4.24. Take it one more. How? 4.240. Okay, we'll leave it at that then. All right, in the other one, we should see that it's going to end up being basically the same thing. So I'm going to do 1.8 divided by tangent 31. What does that come out to? You might take this out a little further. 2.996. Now what we want to do is 4.24 minus 2.996. 1.244. So we want 1.2 kilometers. Now, the reason I had you take that further out is because somebody in here is going to round that up to 3. If I round it up to 3, I'm going to get closer to 1.3 kilometers, right? And if 1.2 and 1.3 would both be answers in a multiple choice question, right? But 1.2 is correct, so it's too close, right? I really don't like that, but it's what we're working with. So that was question 21, and you said sound came in halfway through 22, 23. All right, on this one, I'm going over 6, up 6, so it's actually x minus 6, but I'm going up, so y plus 6. So xy to this, okay? All right, and it comes in halfway through 23. All right, we got as much done as I think we could get done. See ya.